Okay, today we're going to be working with P.5, where we're working on factoring different types of polynomials. And when we talk about factoring, we're talking about trying to take a polynomial apart and look at its smaller pieces. And I mean, when we pull it apart, we have to look at what multiplied to create the original problem. If you think about things like the number 12 and you talk about its factors, well, that 12 could have been created from multiplying 3 times 4. Or 2 times 6. Those would be factors. And these polynomials are a little more complicated than just factoring the number 12, but that's what we're looking at trying to do. Figure out what was multiplied to create this equation. And there's 6 different ways we're going to talk about today, different options for factoring. Now, in an Algebra 2 class, this would probably take us, 2 weeks to go through all of these different options. Today we're going to look at them all at the same time and try to recognize when do we use each type of factoring. The first type of factoring is where we factor out the greatest common factor. This is always a good option if it's possible. It means we look for a common theme throughout all the numbers or throughout all the variables. Does everything have an x? Does everything divide by 3? Questions like that we want to factor out. The next is to factor by grouping. You can't factor by grouping unless you have 4 parts in your equation. If you see 4 terms, factor by grouping might be the best option. Next, we have factoring trinomials, and this is what you're most used to. When we talk about factor by trinomials, you're thinking x and x plus 2 minus 3. These are the kinds of things that come out of factoring trinomials most of the time. And then we have factor the difference of 2 squares. That would be something like x squared minus 16. And that factors, is x plus 4, x minus 4. But the key is that it's a difference of squares. Okay. Notice the 16 has a square root, x squared has a square root. That's your 2 squares. Factoring perfect square trinomials, that's like x squared plus 12x plus 36. This 36 is a perfect square. The x squared is a perfect square. So we're thinking this is a perfect square trinomial. Tri because it has 3 pieces. And then there's the sum and difference of cubes. When you have x cubed plus 8 or x cubed minus 27, and you're dealing with 2 cubed numbers and you're doing addition or subtraction, there is a formula that we'll use to solve those. Let's look at these different types. We'll go through all 6 of them today, or at least try to. We'll go through this first one as our example of factoring out the GCF. And so we're looking at the numbers, the 10 and the 4, and saying, do they have a common divisor, something we can divide by, or common factor? And they both divide by 2. So I'm going to take a 2. And then I want to look at these x's. Okay? This is x cubed. This is x squared. So how much can I take from both of them while taking the same amount from each? If I try to take 3, I wouldn't have enough here with the 4. If I only take 1, that means there's extras left with each of these. So I want to take as much as I possibly can, but I can't take more than I have from any one of the numbers. So I'm going to take x squared. Okay? Then I'm going to start a parentheses where I put everything I didn't take. Now we have to remember that we're trying to create a multiplication problem. So 2 times what would have given me the 10? The answer to that is 5. And x squared times what would have given me x cubed? Well, x squared times x gives me x cubed. 2 times what would have given me the negative 4? That'd be a negative 2. And I had x squared. I don't need any more to make x squared. So this has been factored completely using the GCF method. We pulled out everything we could and left everything behind. Okay? Now we try to do that as often as is possible because it makes the problem simpler. So when we look at this next question, factor by grouping, is there a common number or x through all of the 4 pieces? The answer is no. This one doesn't have an x. This one doesn't divide by 2 or 5 or 10. So we're stuck. What we can do is called factor by grouping. We are going to group the first 2 numbers together, and we're going to group the next 2 numbers together. Now notice how I kept the negative attached to the 2. That's important because this 2 is negative. Okay, so I need to keep that attached there. Okay, So now I look at this parentheses, and I just want to factor this. What do these two have in common? Think about what we did up here in the GCF. Okay. What do they both have? Well, they both have an x squared. So I'm going to pull an x squared out, and we'll see what's left behind. It looks like x squared times x gives me x cubed, and x squared times 5 will give me 5x squared. You guys see the distribution process here? Think about that and ask, does it create the line I have up above? The answer is yes. Over here, I look at what do these two have in common? Well, they don't both have x's, but they do both have a negative 2. And it's important that I take the negative and attach that. So I'm going to write minus 2. And I want to say, what would be left behind? Well, negative 2 times x would produce negative 2x, correct? Okay, and negative 2 times a positive 5 produces a negative 10. Now, that's really important because notice, if you look closely, these parentheses match perfectly. So we have x squared minus 2. That's the outside of the parentheses. We put those together times x plus 5. Now you might ask, how did you know that that would work, or why did you put it together the way you did? I'm going to show you real quickly what this looks like. If you think of it like this, let's say I have 3 times 4 plus 5. Okay? This problem can be written as 3 times 4 plus 3 times 5, right? Okay. So what this is called distribution, right? Okay. So think about it like this. X squared times this minus 2 times the same thing. Wouldn't that be created through the distribution? X squared would multiply by the whole thing, and then negative 2 would multiply by the whole thing. Wouldn't this two-step process, this four-step process of FOIL, produce the same result as this? If you look closely at it, you're still going to take x squared times x plus 5. You're still going to take negative 2 times x plus 5. This is just a prettier way to write your work. Okay? So there's factor by grouping. And again, it only works if you have 4 pieces. We had 1, 2, 3, 4 pieces to start. Factor trinomials is the really common option that we're used to using. We just try, and I just always use sort of the guess and check method. X squared, you know, is x and x. But then we've got to split this 40. Now, we know that we're going to be adding the factors of 40. So if I go 1 and 40, 2 and 20, 3 doesn't go in, 4 and 10, 5 and 8, 6 doesn't go in, 7 doesn't go in, and I'm stuck. So now I'm looking to add these two numbers and see if one of them adds up to 13. Well, right there, 5 and 8 does add up. Okay, the 40 is positive. That just told me that the numbers are the same sign. They could either both be positive or both be negative. If I look over here, I'm trying to create a plus 13. So that must mean that they're both pluses. And we are done with this question. Okay. Some of these will be really simple, other ones will be more complicated as we go on. Here again, we have x and x. That's our x squared. 14, we got 1, and 14, we got 2, and we got 7, and that's all that goes into 14. This is important. Right here, the 14 is negative, which means one of these is plus and one of them is minus. So think about it like we're subtracting to get 5. Well, 2 and 7, if I subtract, gives me 5. So I'll slip a 2 and I'll slip a 7 in. The issue is which one's positive, which one's negative. This tells me I have a plus and I have a minus. So I just have to decide where. To get a negative 5 from adding the two of those together, I would need the 7 to be my negative, the 2 to be my positive, because now I have negative 7 plus 2, that is negative 5. Okay. So this sign here, this last line, tells me, do they match or are they different? If we look at this next example problem, I can tell right now I'm going to have a plus and a minus because that is a negative number. Okay, this gets more complicated right here though, because the 6x squared, I can't split it as x squared and x squared. I have to split it so that I still get the 6. Now you could think about what are my options for 6. I could do 1 and 6, or I could do 2 and 3. You know, I am a fan and a believer in just putting stuff down and seeing if it works. I don't feel like I have to know the answer before I start. And so that's what my suggestion would be to you guys as you go forward, is just throw something down. If it doesn't work, you can fix it. What you can't do is avoid and avoid and avoid making a choice and spend all day doing nothing. So for me, I'm more fond of the 2 and 3 combo, so I'll go 2x, 3x, and then the 7, it has a split as 1 and 7. So really there's some options here. I'm going to go with 7 here and 1 here. Now I'm thinking a little bit ahead. I'm not totally guessing. I have a feel for how this might work, but I'm going to do a quick check. 7 times 3, that's 21x, and 2 times 1, that would be 2x. Now because this is negative, think about subtraction. Could you subtract 21 and 2 to get 19? The answer is yes. To get 19 and to be positive, you would want to subtract 2. In order for the 2x to be negative, this 1 would have to be negative. In order for it to be positive, positive there. So we have that factored completely. There is one other way to do it, and it's not necessarily easier, but some people find that they prefer it. And that is to take 6x squared plus 19x minus 7. And what we're going to do is we're going to times the two ends together. 6 times 7 is 42. Now it is a negative 42. What we're going to do is we're going to split the 42 into two parts that by in ways that will add up to positive 19. Okay, so excuse me, we got the 42 and we've got to split it in a way that'll get us the 19. We're going to divide it to do this, or rather we're going to split it in a way to get us the 19. Sorry, keep getting distracted. And so we have to go through all the different ways in which we could split that. Okay, because this is going to turn into a factor by grouping type of situation. If we think about all the different ways that 42 can split, it could be 1 and 42. It could be 2 and 21. And right here, if we make the 2 negative and the 21 positive, because it's a negative 42, we see we have the 19. So what I'm going to do is do 6x squared minus 2x plus 21x minus 7. And right here you have to understand, negative 2x plus 21x is 19x. So we're replacing it with something that's equal. And now I can do grouping that we talked about earlier. That's a plus 21. So these two have a 2x in common. Start a parentheses. We'd be left with 3x minus 1. Over here they have a 7 in common, so plus 7 times 3x minus 1. And if you look closely, you see the 2x plus 7 that we had over here, and of course you can see the 3x minus 1. So that is factoring trinomials, and that one where you have the number in front of the x squared, sometimes it works better to go and try to do it by grouping, but it does take a little bit of precision. This up here can get really messy if you're not careful. Okay, the factoring the difference of two squares. The first thing you have to recognize is that both of these things have square roots and that it's a subtraction. And so we're just going to use the square roots. Well, what's the square root of x squared? X and x. What's the square root of 36? 6 and 6. And because this is negative, we talked about this earlier, last number tells us whether we're going to do same signs or different. We have a plus, we have a minus. Down here, does 25 have a square root? Answer is yes. Does 64? Yes. Is it a subtraction? Yes. The square root of 25 would be 5, so I'll do 5y and 5y. Square root of 64 is 8 and 8, and of course, because it's negative, I'll do a plus and a minus. Then Okay, and so then we have this last one of these right here, where we're going to factor. And you notice the x squared is not x squared, it's x to the fourth. Well, just what would the square root of x to the fourth be? It would be x squared and x squared. And like all these up here, we know we've got a plus and a minus because it's a negative. Well, the square root of 81 is 9. Here's where we can get you into some trouble. X squared plus 9, it's plus. It's stuck. There is nothing that can be done with x squared plus 9. But if you're not paying attention, you might have thought that was it. You were done when you had that first factoring done. But x squared still has a square root, and so does 9, and this is a subtraction over here, meaning I can split it one more time into x and x, plus and minus. Square root of 9 is 3 and 3. So sometimes, if the exponent starts out big enough, we might be able to factor more than once. And these are great examples of problems that factor more than once. The next group we have is the perfect square trinomials. And they're really straightforward. Super easy to factor. We use square roots a lot. One thing to keep track of is, what's the square root of 9? Well, it's 3. What's 3 times 2? 6. That tells me this is going to work. If taking the square root and timesing by 2 gives you the middle number, that means you're set. So this is going to be x and x, 3 and 3. Now this tells me the signs are going to match, and in order to get a positive 6, it better be plus and plus. Oftentimes, because of the duplication of these, we'll write it as x plus 3 quantity squared. Either one is acceptable. This is definitely preferred. And you need to be able to recognize it when you see it. Down here, the 16 has a square root. The 49 has a square root. Let's real quickly look at what they are. The square root of 16 is 4. The square root of 49 is 7. If I times those together, I would get 28. Guess what 28 times 2 is? It's 56. This is going to work. The reason that we have to times by 2 is because right here you have 3x and 3x. That's twice that you get the 3x. When we factor this, we're going to go 4x, 4x, 7, and 7. See, 4 times 7. This is where I'm checking the 4 times 7. That's going to give me 28. But I'm also going to get a 4 times 7 on the outside, which gives me another 28. That's the 56. The signs have to match, but in order to get a negative 56, I'll need these to be negatives, meaning my answer is 4x minus 7 squared. Okay. The last thing we need to look at is the sum and difference of cubes. Now these are special because they always factor one step. Okay, so look up here. We have a cubed plus b cubed equals, so if I want to factor it, I'll get a plus b without any cubes times a squared minus ab plus b squared. Now a and b are whatever's being cubed. Okay. If it's subtraction though, notice I get that subtraction here, but look what happened over here. Okay, these signs switch. I'm only allowed one negative. It's either the first sign or the second sign. They will trade based on what the first sign is, and the first sign always matches the original problem. So the first thing you might want to do with something like x cubed plus 8 is recognize that we're looking at this pattern. But also, what's b in the problem? You can't say that it's 8 because 8 isn't being cubed. You need to replace it with something that is being cubed. So what cubed would give me 8? We got to think about that. What times itself 3 times gives me 8? The answer is 2. So this problem is not x cubed plus 8. It's really x cubed plus 2 cubed. So that means that x goes everywhere that a is, and 2 goes everywhere that b is. Meaning if I take this problem right here, I'm going to get an x plus a 2. That's a plus b times a squared would be x squared. Now, because I started with a plus, I'm going to go with a minus. AB, that would be x times 2. So I get 2x plus, this is always a plus, b squared. Well, 2 times 2 is 4. Now you might look at this second parentheses and say, hey, can we factor that into two parentheses? Because it's a sum or a difference of cubes, this will always be the end of the line. It will never go further than this. So I can guarantee you, you are done with a sum or difference of cubes after you do that one step. These formulas are very important to remember and to work with. We want to distinguish what they look like, okay? Well, good luck, and we'll see you in class.